Hey, what you're looking at here is a battery out of my 2000 watt 60 volt scooter. Now this was a 60 volt 13 amp hour battery. And I only had this scooter for probably 5-6 months, and I stored it for the winter. I brought the battery in the house, and for some reason when I hooked it back up it did not work. And I'll get into details on that, but this video is going to be, I'm going to build a battery from scratch versus buying a new one. I want to film this. I'm going to be learning as I go, but I do believe I got all the components to it. As anybody would know, batteries are quite expensive, and I want to build a longer runtime battery, save a lot of money. One thing with this video build is going to be minimal soldering, and maybe only the BMS wires will be soldering, and we'll cover that, and there will be no spot welding or anything. It's going to be screw in together. This battery has 80 18650 cells in it. And what happened, you see there was another one there. I put 5 Panasonics because this whole bottom bank or parallel group of batteries basically completely shorted out. This is my contraption here trying to solder on it. It does not work good soldering on batteries. 18650s, but I did get it to work. But somewhere in here, these are drained down, and either it's so out of balance or I got another dead cell or two in there. I don't know. The battery itself was 5 parallel and then 16 series, which ends up being like 67.2 volts fully charged. And I think I'm going to try to reuse this BMS. I bought another one, a 35 amp, but I don't know. Thing sure seems small. With that said, what I got to do is start ripping this up completely apart and salvage what batteries I can out of this 80 pack. And I had bought on eBay, which I could provide the links to everything that I bought, 100 Panasonics. Now these were used. Company on eBay basically repurposes. They rip apart stuff. They test these out. They guarantee them over 2,000 milliamps. These are the Panasonic Bs. I do believe they might be high drain. I don't know. I've got all these charged up to 4.1 volts. Now, I only paid $180 for all 100 of these. I want to salvage enough batteries out of this that I want to run a 8 parallel and then 16 series, so 8 times 16 would be 128 batteries versus 80. And how I'm going to do that is there's a company that I'll provide the link for that they were on Kickstarter, I think, for about a year, and it comes with these little plastic connectors. You can run these together, and I got enough. I ordered 3 sets. Each one can do 54 batteries, so I got enough for over 160 cell battery pack. But it comes with everything, all the screws, the plates, and everything. If you're interested or you're wanting to build your own battery or attempt to, go ahead and watch this video. Keep in mind, it can be dangerous messing with these batteries, so you do it at your own risk. I'm going to get ripping this battery apart, these tested out, and we'll start on this. Alright, I made some headway. Skip all the videoing of me dismantling that other battery. Here's some cells from it. What I want to do next is show you how I'm doing this. This is awesome. Really liking it. Right now I have 11 series in 8 parallel. So 88 batteries. Now what I ended up doing was, as you can see here, these are the used Panasonics that I bought. I've tested them on this tester here, and them are running about 2100 milliamps, and I'll get to this. I'm trying this out. The ones that were in it right here, almost every one of them are good. Them are running about 2500 milliamps. So versus using, say, 100 or 80 of the Panasonics and having all Panasonics in a parallel, and then, say, a thing of 2500 and 2100, I mixed them, and I think I'll be all right. So I got 4 Panasonics, 4 whatever them were. My guess they were Panasonics because they are a good battery. I was impressed. So that should even that out. What I'm doing here is, once it's done, I'm draining this set. I want to see how many milliamps it is. Milliamps I'm going to get out of a pack. So I'm hoping somewhere around 1800 amp hours. But anyways, this is pretty neat right here. And before I start that, if someone is taking apart old batteries, you get these cutters here, flush cut, side cutters. Boy, do they work good. Taking off the welds. It's just unreal. What I did is magnetize the end so them little fine pieces of metal stick to it, and then you pick it off. Does a great job. Just wanted to throw that in there. I'm going to go, I got 11. I got room for 14 that way, and then I'm going to put 2 here. I had a diagram to show how I was setting this up. I don't know where it is, but I want to show when it comes in these packs. Each of these packs you get 104 terminal caps, which you'll see how them work. That's awesome. And 6 wire clamps. And you get 130 of these bus bars. And then 104 of these little, I think they're 5 or 5.5 millimeter nuts. They're small. And 6 large cable ties. That's what you get in a kit. Now, what I'm going to do is just do one set, show you how to attach these terminal caps. It's pretty self-explanatory. You have to figure out what way you go, because if you look at these, got a flat spot, and then 2 male ends. And what I'm doing is going across. You put them all one way. So right now I got the negative are blue, positive are red. So on the bottom of this, I'm going to flip it over. I'm going to do these in reverse. And what I'll do is get 8 of these ready, and I'm going to speed up the video showing you how this thing works on at least just one set. I've been popping these tabs out a little bit inside just to play it safe. Basically just slide it on, and I'm already doing it wrong. One thing, double check. So I want negative on there. I want to alter it. Get it the right orientation, slide it on. I've been using a rubber mallet to tamp them down. Flip it over. Yep. I'm going to take 4 of my used Panasonics that I ordered, and this is where double check. You're going to put the negative in on this row. Then 4 of my other scooter batteries. Now what do is you start with the positive terminals. Now I'm going to go this way. That's all there is to it for putting the caps on anyways. Now this whole thing's going to get pressed with wood when I'm done, and you double check, make sure you got all your positive and negative terminals in the right location. So now that's 12. I got to do 2 more, and then I'm going to run 2 along here. That'll be a 16S battery, and then we're going to end up putting bus bars all on. I'll show you quick how I'm doing that once I get this other part on, and I'm still on the fence about the BMS. I guess I'm going to throw the BMS on just to make sure. But I'm going to go ahead and get this rolling and get all these on, and then we'll turn the camera on, show you the screwing in the terminals. Alright, check this out. This power pack's going to have roughly over 1,800 amp hours of runtime. Almost 1,900. They had 18,736 milliamps out of the 8 battery parallel setup. And I'm going to show you how I got this number. How I ended up testing this battery pack of 8 batteries in parallel was I got this typical charger. This one now will discharge and test your milliamp hours on your battery. Took a dead battery and I just wrapped electrical tape around it just to make sure it didn't make contact. Put 2 pieces of metal tabs in and hooked 2 alligator clips, positive and negative, and one side on here like the positive, and it doesn't matter where as long as the other one's on the negative. And then you it'll actually start charging. Fortunately, I had a whole old pair of needle nose bent tip laying around. I actually think I found these magnet fishing, but these work real good for putting them little nuts on. When you're putting this together, the farther I go, of course, the more the voltage is going up. So right up here, you're talking probably pushing 60 volts. Now, putting your caps and everything on, double and triple check your polarity, and that's a must. I've messed up more than once, and I caught it double checking. What I'll do is I'm just going to make sure that I'm not going to get a spark from it, which I know I'm not. So I'm going to go parallel first and lay these down. And then to the negative side. Okay, so they're all parallel. Now right here is where the potential is. It could short out if you have your polarity wrong. Got worried there. I heard it banging. Well, we're good. What it was is one of them rattling. Now we're going to take that, turn it into a series. And then the delicate work. Take my 5mm or 5.5mm and just start screwing these all in. Get them fairly snug, and if they're not going tight, I back them off, or if they're starting to go on crooked, back it off a little bit, and that seems to catch the thread. Not overly tight, but not loose. You don't want these coming loose. Look what I did there. Getting in a hurry, I forgot one bus bar. Eventually I would have caught it. Now that I got that done, I'm going to flip it over and show you what I'm doing. So now, juice is going down from this negative down and then up this positive. Now if I would have had the room, I would have went just 8 parallel and 16 this way on my scooter, but the compartment isn't big enough lengthwise this way. So I have to put these on the side. And well, now what I'll do is put parallel here, and then I'm going to have to run a jumper wire. This one I can use a bus bar, but then, this one I can use a bus bar, but then this one I'm going to have to go to there with a wire to there, and that way I know I got the proper amount of wire to pull that amperage through. We'll get that done. Right now what I'm going to do is just test the voltage just to see the ground to the positive. Now one thing, till I get these all compressed down, some of these might not be making a good contact. There's the ground terminal. I should be able to hit right here, and I don't know how many volts I'll get. 58. Now if you notice there, it's not doing it. What it is I got to tap them down. Oh, yeah. Been flipping it over so many times. I compress everything sandwiched together with wood, so not too worried about it yet. Damn, I still ain't got one. There we go. See? So it's going to be very important to compress that down. So 58.62 volts. And the goal, of course, is to get about 67 when I'm done. And this will be the end of my positive. Should be 67 volts right here if I connect the ground and that, and I should be able to put my BMS, if I'm going to use one, right here, and everything should fit in good. So I'm going to get that done and then show you that setup. All right, I got all the bus bars and wiring hooked up, and if I were to take my multimeter, go from the negative terminal to the positive, 66.8 volts right now. So now what I got to do is hook up my BMS and the wiring. And then I'm going to get the wiring hooked up, not bore you with soldering and everything like that. I'm going to minimize soldering, by the way, but I'm going to have to on some terminals. And these BMS wires, I don't know what I'm going to do yet. If I'm going to unscrew, pull insulation off and unscrew it and just screw it back on, I might do that to simplify things. Coming out pretty good. Alright, I got the BMS installed. It was a bit of a pain, and I'm going to try showing you what I did. I got a mass of wires wound up on the side because I'm very limited to room on the end. But these are going to be sitting here, which is fine. And this BMS was actually a 17 wire string. It started out with a black wire and then ends up with 2 reds. And that black wire gets soldered to, hold on, that black wire gets soldered to the negative lead on the number 1 parallel string of batteries along with the negative power. And then, as you can see here, this was a split BMS. B is to the battery. So I'm going right to the battery of that one. P is to power, and that goes up, comes out, and that's going to plug in to my controller. And then C, which is down here, that's going to the charger. And the charger, hot wire, is going up to the 16th string on the positive. And that's, there's hot glue on there. That isn't that big of a blob of solder. The power, of course, which is fused, is going to go to my controller. Everything works. I get 66.6 volts right now. As far as the 16 or 17 wires coming out of BMS, the first one's going to the negative. And if I got it right, the directions weren't very good. The second wire is going to go to the positive. I mean, I think it can go to this parallel set here in between them. It doesn't matter. So then you get the second one there in succession. Third one's going to that one, which was a black one. Fourth one's a red one going to the next string up. Fifth one, sixth one, and you work all your way up till you get your last wire, which is the 17th wire, gets soldered into the hot positive side. And your 16th wire, of course, was on your last string. Hard to explain, but that's how it works. All right, the boards that I was going to sandwich this in between actually were created it to be too high, so I couldn't shut the lid on my scooter, so I had to redo it. And the biggest problem that I was running across on these caps is on the Panasonic batteries. Tops of them are a little bit smaller diameter than, say, these other ones. These caps can work loose rather easy. The solution was I put zip ties on every parallel set. Tried to clamp it down as tight as possible, which wasn't working the greatest. And the solution to that was, once I had the zip ties on, I slid in some furring strips. That'll also help with the bottom. That seems to keep everything compressed good. But other than that one issue, I really like this thing. My solder joints on this whole setup was only in a couple spots, and that was in this contraption, the BMS. I think 1, 2, 3 soldering onto the BMS, and then of course the negative and positive. And that was it. Everything else, the BMS wires, I slid in between the bus bars, clamped it down. So you literally can do this with almost not any soldering. I took it for a ride, tested everything out, works quite well. So now the final step on this is I'm going to take some rigid styrofoam, lay that on each side, and then I cut a PVC off the bottom of or the lid of say a big Tupperware container, put that on, and I'm just going to cheat and use a roll of duct tape and tape this thing up. And I doubt I'll have any issues with that. Thought about going elaborate and getting shrink wrap and stuff like that, but I don't. This is basically free and probably do a better job. So I'm going to end up getting that done, and then we'll take you outside and show you this thing in the scooter and show you how well it works. All right, I got it done. Duct taped it up, got rigid foam and the plastic off lid from like a tote. And this is the original battery box. Now this one housed 80. And this one I got 128 in. And this one would cost probably $350 or more new. This is a 12 amp hour, 60 volt. And this one, I tested it out on a parallel bank. It's roughly between 1900 and 19,000 and 20,000. So which is pushing a 20 amp hour versus 12. Pay about $350. And I got a little over 300 into this, including the extra batteries that I used out of this if I were to buy them outright. So saved quite a bit of money, and the good thing is not having to go spend the money and buy another one of these if they go out, which I didn't have no luck with that at all. I can just cut this open and replace the cells that are bad. And we're going to take this outside, and I'm going to show you this installed into the scooter. And I do got everything sealed up pretty good. And I did test it as far as a thermal camera, and never seen anything heating up, which I'll show you. It was actually the wiring going to the controller and back to the motor gets way hotter than this wiring. Let's go out and get her installed. All right, so here's the scooter. It's a 2,000 watt hyper racing scooter. I've had pretty good luck with it other than the battery. I've had it close to a year now, and of course I didn't drive it at all in the winter, and somehow that battery went dead, malfunctioned, and I do believe, could be wrong, but I think it was the BMS from the beginning. But I'm going to show you, I'm going to put that battery in and how little a room I got. So I planned it out about right. Put that little wire hook there, hold that up. The controller's right in here, so I had to take, there was bolted metal plate in. That ain't got a lot of room. Look at that. Tight fit or what? I got just enough room to put my toolbox in there. Spare fuses. Now, on this controller here, or display, if you look there, 65.6 volts, that's been sitting overnight. 65.6, and when I do charge it, I'm up to 66.8 when it's fully charged. So, it does pretty good, and I've driven it quite a bit. I'm going to take it for a drive now and show you. The scooter's got a horn, lights, everything else on it. Capable of going up to 40 miles an hour. But I got a gear reduction on it, so I'm only getting maybe 30 tops if I hit. You got your low mode and your high mode here, or turbo, whatever you want to call it. Generally run it in low mode, it goes up to 18, and I use this scooter, it's an off-road. Use it for out in the fields and stuff. Get out of the way, cat. Then you hit the old turbo. Kids are up in the field and they get up there. Even bogging down, I'm at about 56.7 miles an hour. I weigh 220 pounds and can almost keep up with a go-kart going up the hill. Pretty awesome, I think. I'm impressed. Not only did that battery work out, but I got extra battery life, and if something goes wrong, I can take it apart. A little bit of dismantling, but it ends up can replace individual cells. If somebody has questions about anything, go ahead and write. It was a good learning experience for me. I'm no expert at it, but like I said, you're at your own risk when you're working on these things. A lot could go wrong if you don't do it right. I did short it out one time when I was, I don't remember what I was doing, but I arced it across at about 60 volts, and I could feel it a little bit, but it's DC, so it's not like AC current, but I wouldn't take the risk. Use gloves and everything when you're messing with it, so. All right, well, I hope this video helped, and I'm good to go. And I really like the thought of them, that company with the do-it-yourself connectors. I might do some more video on while I'm driving, we'll see. Well, to me, 29, 30 miles an hour is more than fast enough on this thing. I might end up buying a different gear for the back and gear it down even more. I'm at, I went 1.4 miles just now, and I'm at 63.2 volts. I'm going to keep driving it. Here's the acid test here, about a 30-degree incline. Man, getting up there. I made it. Sitting idle, I'm at 60 volts. Down to 54.4 going up the hill. 53.7. I got my light on yet, but I'm at, said it'll slowly climb back up. 59.5 for voltage, and just over 5 miles, almost 5.1 I've traveled with this. And I've been running 35 minutes up and down hills and out in the road. So I'm impressed with this. Should work out good. You know, I'm up to 59.7, 9.8. Like I said, it's hovering around 60 volts. I think 50% is probably about 58 volts, maybe a little bit less, maybe like 56. Just on the road, I could I'd easily get 20 miles or more with this, I would think. Pretty awesome. Pretty awesome.